Okay, thank you, sir. Okay, okay. Thank you. Good evening, Abhinav sir.
Take seconds.
Yeah, good evening. Good evening, sir.
Hello, Abhinav sir. Welcome, sir.
Good evening. Good evening. Good evening.
Welcome, sir. Welcome.
Welcome. Thank you. Thank you.
So, just we are waiting for the 5 minutes, sir. Let's join the other participants. So, we are
Sure,
waiting
sure.
for 2 or 3 minutes. So, Bini sir, let's start. I think.
Yeah, that's good. Uh, okay, so let's start this. Uh, Good evening, everyone present here. I am Vineet Raj Singh Kishwa, Organizing Secretary on behalf of the Organizing Committee of the 6 Days Faculty Development Program on GenGeo AI, Synchronizing Generative AI, GIS, and Smart Technologies, and Sustainable Agriculture. Feel honored in welcoming you all on the second day of this FDP, organized by IPS College of Technology and Management, Gwalior, with the support of AICT Atal. This program stands a testament to our collective commitment to professional growth, academic excellence, and fostering a community of lifelong learners. So with this, we are proceeding for the third session of 6 days faculty development program. I invite Dr. Abhinav Tomar, Assistant Professor, NSUT, Delhi. But before his speech, I take this opportunity to present bio sketch of Professor Abhinav Tomar. Dr. Abhinav Tomar is an assistant professor in the Department of Computer Science and Engineering at Netaji Subhas University of Technology, New Delhi. He earned his MTech from MNIT Allahabad, PhD from IIT Dhanbad, and his research interests include wireless rechargeable sensors network, cloud computing, nature-inspired algorithms, reinforcement learning, and quantum computing. Dr. Tomar has authored more than 25 research papers, holds 2 Indian patents, and has received Young Researcher Awards in 2020 and 21. He serves as a reviewer for leading journals like IEEE TBT, IEEE TMC, and Computer Communications. And he is an active member of IEEE, ACM, and CSI. I invite Professor Abhinav Tomar to deliver his talk on reinforcement learning and generative AI applications for smart and sustainable agriculture. It's over to you, sir. Abhinav, sir.
Yeah, good evening. Good evening. Yeah, thank you, sir, for the introduction, and good evening to all. Let me start my PPT now. I will be sharing my screen. I hope is it visible to all now?
Yes,
Yes,
visible,
sir.
sir.
Is it okay?
Yes, sir.
Yeah. Okay. So today's topic is reinforcement learning and Gen AI application for smart and sustainable agriculture. Okay. So before moving to RL, let me talk about AI and ML. That is very, very important part. Then we will jump to RL, and also we will discuss some applications of Gen AI. So when we talk about AI, some definitions that are involved in book, and we must understand what they actually mean. So artificial intelligence, if we talk about the application, a definition of Richard Knight, the definition focuses on human-like abilities. Okay, and we are trying to bridge the gap between human intelligence and machine capability, actually. And when we are saying at the moment, we are meaning by that AI is highlighting basically, I can say, continuously catching up, and today's impossible becomes tomorrow's standard. Okay. So, can you think about something computers could not do a decade ago? Can you name one? Now we can imagine that. Okay. Possible answer like speech recognition is one of the application. Translating language is one of the application. Identifying crops for satelliting images, generating images for the text. These kind of application we are talking about. Okay. So if we talk about real life agriculture examples, like one of the possible example is leaf disease recognition. That is very, very important. So earlier only experts could diagnose it. Okay. Now, but with the AI, we are detecting disease better than humans in some of the cases. Okay. And if we talk about bead versus crop differentiation, then humans need to manually inspect the fields, agricultural fields. But now AI drones are doing that. They are making real-time decisions. Or if we're talking about yield prediction in the agriculture, farmers, they are relied on the experience actually. But now AI combining the soil data, and we can say rainfall history, okay, and satellite vegetation indices, all these things. So AI basically imitated human abilities, okay, and that is what this definition is all about. So Gen AI now, If we talk about Gen AI, it is now creating what humans never produced. Can you give me some examples of that? Like synthetic rice blast images, I can say. Have you heard about rice blast disease image? So that to train the model, use them, that is possible with Gen AI now. Or generating missing weather data, possibly for the remote regions. Okay. And we can say producing soil nutrient distribution maps. But because important is that because we have limited samples. And with that, creating that is the beauty of Gen AI. So if we talk about next definition, that is Winston, we are talking about three things: perceivance, reasoning, and action. Okay. So perception means we need to understand the environment first. And reasoning means we want to making sense of what we have perceived. And action means we want to take decisions that changing the environment. Okay. So if I show you a plant leaf with some spots, okay. So what happens in your brain? That is my question to you. What happens in your brain? So, I mean, how you can divide into these three things: perceivance, reasoning, and action. So, perceivance means I see brown patches. Let's suppose I am seeing the brown patches. And that if I do this, the AI equivalent, I can say this is a part of image segmentation and feature extraction. Okay. If we talk about the reasoning, what reasoning I am getting from those patches? I can say it may be fungal infection, okay, like disease classifier. And lastly, action. What action I'm doing? I'm spraying fungicide or isolate that area. That may be the solution. So that is decision support system. Okay. So the theme of this FDP is basically agriculture plus GIS. So if I combine that, I can imagine some examples like precision irrigation system. So what perceivance I am doing? Soil moisture sensors are there, and satellite soil reflectance are there. Okay, and what reasoning I am getting? We are predicting the water stress there. Okay, and actions, I am opening the drip values automatically. That is my action there. Okay, so if I can imagine another example, that is GIS based pest surveillance. That is very, very important nowadays for research purpose. So perceivance means I can imagine like pest trap counts, maybe that is one kind of things. And field temperature, agriculture field temperature, that is one kind of thing. And what reasoning I am getting? I am spatial risk clustering. That is my reasoning. I need to do that. But action, what I am performing? I am recommending zone specific spraying. Rather than complete, I'm focusing on zone specific spraying that. Okay. So how we can connect all these things to reinforcement learning? That is important because we are perceiving the state. We are reasoning through value and policy, and we are doing some kind of action to maximize our rewards. So that we will understand in the reinforcement learning part. Okay. And if we move over to the third definition, that is Charnak definition, that definition is treating AI as a scientific experiment, and we want to understand the mind. Okay. So focus is on modeling thinking. We are talking about modeling thinking here. We are talking about modeling learning here. We are talking about modeling memory here. Okay. So humans learn from past harvesting. Let's suppose if I'm talking about some analogy related to agriculture, and AI learning from the historical data sets. So both we are trying to mimic that. We are trying to modeling the brain process. Okay. So can you imagine how a farmer remember the things? A farmer remembers that late, if it is performing the late sowing, then it is reducing the wheat yield. Can I say that? that is human. It is working like a human memory. Okay. And AI is basically learning the same correlation from the data. And that is what computational model is all about. Okay. So how this is relevant to GenAI? Because GenAI is learning the internal representation, and it is basically generating the novel outputs. And that is functional similarity to human imagination. If we have hundred of images of tomato blight, then how can we train a strong model? That is my question. Okay. So GenAI is the solution. Okay. So that is important because now we talk about the machine learning. And if we talk about the historical evolution, I mean, initially in the 1950s, uh, we are talking about symbolic AI, and then later on we talk about interconnecting of the systems, and then we talk about domain specific deep dives. Okay, so in the agriculture, we are getting the evolution with the technology, and nowadays we are using it in the bytes perspective. So machine learning is a specific branch of AI, we can say, and what this really means, because software engineers, they wrote step-by-step instructions. Traditionally, we talk about without any machine learning, and the computer is following the rules, whatever they are writing, and no learning is there, no adaptation is there. But with the machine learning, it is flipping the logic. Basically, we are not telling the computer what to do, actually. We are showing the examples. And the system figures out the rules on its own by seeing that images. Okay. So traditionally, we are talking about if and else rules and manual logics. But nowadays, with the machine learning, it is learning from the data. It handles new unseen scenarios, and that's why it is we are making it adaptive. So if we talk about in the perspective of agriculture, then I can say old method, what is saying, we are processing some rule, like if soil moisture is less than 20%, then start irrigation. That is one kind of rule I can define. But now model that is learning optimal irrigation pattern, they are doing that from yield history, the types of the soil used, and rainfall, or I can say satellite NDVI, all these things. Okay. Now model is predicting. What model predicting there? Model is predicting when and how much water each zone needs tomorrow. That is the prediction by model. Okay. So how this can be connected with the GIS, because ML is learning spatial patterns. We are talking about the spatial patterns. Okay. And if we talk about the land use classification from satellite imagery, that is one kind of examples, or I can say mapping soil nutrient from let's say very sparse samples. Okay, so GenAI basically creating new data, because ML is learning from the data, but GenAI basically creating the new data like synthetic soil maps. That is one kind of example. So our definition is given by the Michel, and the classical definition is basically involving experience. Experience means we want better performance on a task. Okay, so illustrate with the everyday analogy, I can say very simple example I will give you. Those who are new to machine learning, or those who are still working in the infant stage. So human child trying to learning a cycle. Okay, and the task is that we want to ride a bicycle. But what is the experience here? We give him some practical sessions. Okay, so performance measure, what can it can do? Distance without falling. That is the goal. If somebody is trying to learn the bicycle, it want to he or she want to learn without any falling. Okay. So if more data is there, the number of errors will be few. Okay, and the decisions will be better. That I can say. So in the agriculture, what task I am performing? Let's say I am predicting the crop yield. That is one kind of task. Now, what is the experience I am getting? What is the experience? Past 10 years of rainfall, or I can say past 10 years of soil readings, fertilizer usage, whatever it is, it has been done, and pest outbreaks, all these kind of history I need. And how I can do the performance measure? I can doing that with RMSE. That is, we want to minimize it, error between predicted and actual yields. So that I need to predict. Okay. So as number of seasons are more and more, the prediction accuracy will be increasing. And that is the learning. Okay. That is, we are saying the learning with experience. Okay. So ability to learn from the data is very important. Okay. And what data sources I'm talking about? Data source may be, sensors, maybe they are collecting the readings, domain knowledge, okay, experimental runs, and what other else, remote sensing plus GIS and crowdsourced data, all these kind of data sources I can use. And what about the learning? Learning means I need to optimizing a model first, and that model maybe having some specific objective, like I want to minimize the fertilizer waste. That is one kind of objective. So when I am talking about the human machine interaction, and so that is very important, because I am learning from the experience, and machine will saying I learning from the past data, through machine learning. That is same. Okay. So let me give you some examples. These are basic examples: a handwritten recognition problem, a robot driving learning problem, a chess learning problem. All these are related to things, and I have categorized between task, performance, and training experience. So if you see the first example, that is handwriting recognition, and if you read the slide, then my question to you, why we can't write one program that can recognize all handwriting styles? What will be your answer? Can somebody give me answer in that? Why can't we write one program? Is there any answer for that? Because we have too much variation. Variation is very vast. And it is impossible to hand code the rules. ML learning patterns from the examples, but by humans, that is very tedious task, I can say. Okay. So suppose if I'm replacing the handwriting with leaf disease patterns. Okay. So that is same. The problem is same in the agriculture perspective. Okay. And what my task is, I want to classify the disease type from the leaf photos which I have. And what performance measure I am using? Accuracy, or I can say F1 score. Okay, that is my, and what experience I am getting? Data set of labeled plant images that I have. But what GenAI is adding in that? Can you give some examples? If the data set is very small, then the use of GI is there. GenAI will generate synthetic disease leaves, or it will improve the model robustness, I can say. Okay, so these technologies, they are combined to each other. Okay, and if we talk about the robot driving learning problem, that is also, you can see, that is used in industry nowadays. Robots and driving on the highways using vision sensors, that may be one kind of task. So ML learning from the patterns, and reinforcement learning, learning action through rewards. Okay. So If I'm talking about the robot driving, how you can relate it with the agriculture? Can you give me one example that can relate it? The examples can be, I can imagine a tractor, and that tractor may be self-driving tractor in agriculture and in agriculture farm, and it can learn the optimal harvesting path to reduce what it can reduce to fuel, to avoid the obstacles, and to minimize the crop damage. That's one kind of example I can relate it. Okay. So every example that can be related with some application. Okay, because when we are working on a research problem, the first step is to identify the problem statement, how to map something into your problem. That is very, very important task. If once it is done, your 50% task is done. Okay. Now, if we talk about the chess learning problem, you can see how you can relate it with the modern agricultural analogy. Can you give me one example? You can think of a chessboard as a farm field, agricultural farm field. And if you're some actions you are performing on the chessboard, like that you are also performing some action on the agricultural farm. What those actions may be? You are doing irrigate, or fertilize, spray, all these actions you are doing. And that is affecting the future yield, not just the current state. You are concerned about future yield, not the current state. Okay. So your reinforcement learning basically learning the best sequence of the actions across full crop life cycle. Okay. So if we talk about the process of ML that can be defined by these 5 things, and most ML projects, they fail not because the model is wrong, but because problem was poorly defined. That is very, very important. Because you must answer, what exactly are we predicting? For whom? I can say, why does it matter? Or I can say, what decisions will change because of the prediction which I am doing. Bad problem statement क्या हो सकता है? Use AI in agriculture. That is a bad problem statement. Use AI in agriculture. Are you getting something from this problem statement? But what is a good problem statement? You predict tomato leaf blight 7 days in advance for the farmers in Madhya Pradesh, let's suppose, to reduce the pesticide usage by 30%. That is the good problem statement which I'm giving. So problem statement is very, very important. And if I'm talking about the agriculture focused examples like crop disease, irrigation, spraying, yield, supply chain, all these things, you can relate it. What kind of problem statement are there? Early detection of the rice blast. Or I can say recommendation of optimal watering schedule. Or I can say predicting which wheat yield before harvesting stage. That is one problem statement. So finding out the problem statement is very, very important. And if we're talking about the spatially aware problem statement, if we're talking about the GIS, spatially aware, what kind of problem statement you have? Which districts are at the highest risk of pest outbreak next week? If I'm talking about the districts in a state, so which district will be having the highest pest outbreak next week? That is one kind of example. Or generate soil fertility zones using sparse sampling, or satellite data. That is one kind of example. So forming a problem statement is very, very important. Next step is data collection and cleaning. What do you think? What data really looks like in the world? कैसा दिखता है data आपको? If you have really worked on that, you can imagine it is missing actually. Many fields are missing. Sometimes it is noisy. It is inconsistent. It is biased. It is incomplete. All these things. Okay. So what type of data we can imagine in the agriculture? Can you give me examples? What kind of data we can imagine in the agriculture? Agriculture, we are talking about the sensor data. We are collecting from the sensors. We are talking about the satellite data. Okay. So if we go in the specific detail, historical records, and we are talking about the weather data, we are talking about the manual observation, all these data we are getting. So if we're talking about the sensor data, what I can have? Soil pH, moisture, temperature, EC, all these things I am getting. If we talk about satellite data, that I was talking about the NDVI, EVI, all these things. Historical records, what you can have? Cropping patterns, yield logs, which if you are generating the yield logs. So, and if we're talking about the weather data, we are talking about the rainfall, we are talking about the humidity, we are talking about the wind speed, all these things. So what cleaning tasks I have in this? Can you give me some examples? What cleaning tasks I have in the agriculture data? What cleaning task I have? I need to remove duplicate sensor readings if I have. I need to interpolate missing rainfall. Have you heard about interpolation? Or I need to correct the faulty pH readings. Or I need to normalize the units because the units may be different. That is also one kind of task. So cleaning task is very, very important. Okay. And when the data is limited, where the data is imbalanced, what we are using? We are using GenAI. Okay, that is the importance. Next, model building. Model building is very, very important. Okay, the core idea, we need to select the right algorithm. And how I will select the right algorithm? That must be based on types. किसके types? Data types. जो data type आप use कर रहे हो, that. And prediction outcome क्या है हमारा? That is important. हमारे constraints क्या है? What constraints we have? So let me give you some examples. You will relate it like disease classification. What data you have in the disease classification? You have number of images. Am I right? You have number of images. And what model you are going to perform? CNN may be the one solution. If I'm talking about yield prediction, what data you have? You have, let's say, tabular data plus weather data. And what model you are going to use? Which model you are going to use? Some regression models may be there. If I'm talking about the, let's say, soil zone grouping, what data I have? I have unlabeled spatial images. And what model I'm using? Maybe clustering. Clustering may be K-means, DB-scan, all be study in ML. Okay. So if I'm talking about the agriculture example, predict mango flowering time, maybe mango flowering time, maybe, and how you can do it using temperature, humidity, or past blooming cycles, all these things that we have. Okay. So model building is very, very important. Now, if we talk about the training the model, what do we mean by training the model? And model learning patterns by minimizing the error. Can I say that? And that is the meaning of training. So what happens internally? Because we have forward pass that during the prediction. Then we are comparing versus truth, what we have. Then we are computing the loss. And then we are adjusting the weights in the algorithm. And we are repeating it thousands of times until we are getting the desired results. So one example may be training the rice disease classifier based on, let's say, 1,000 of images or 10,000 of images, or we can say 80-20 split testing or training data. Okay. Or we can say we can use color jitter there. Some constraints may be there. Okay. So lastly, we have evaluation and feedback. Evaluation metrics. What evaluation metrics we can have? If I'm doing the classification, I can have accuracy, F1 score, precision, recall, all these things. If I'm talking about the regression, I can have RMSE, MAE, all these things. If I'm doing the clustering, I can have CULET score. Or if I'm doing time series, maybe MAPE or SMAPE, all these things that we have. So if it related with agriculture, I mean, if the disease model is, let's say, 92% accurate, but poor recall. So what we are observing that missing the sick plants actually, and it is useless in the real world. So feedback loop is also important. I mean, real world deployments, they improve the model by farmer feedback or new weather patterns, let's say, or new pest varieties. So that is important. Now, this is the process you can understand. I mean, first we need to understand the user needs. Then we need to define the objective. Then we need to collect the data, then training and testing a model and predicting evaluate. You can understand that this is the iterative process. Okay. And the need may be defined by the user in terms of the objective of the problems. That may be anything. Okay. So that you need to understand. And here you can see this is the iterative process actually. This is the iterative process. Because after prediction, you are again doing the same thing and until you are getting the result. And that iteration is going on, you are refining the model and until you are getting the results you are actually looking for. Okay. So when you go from 10,000 examples to 10 billion training examples, it all start to work. Data trumps everything. So that is one kind of, solution. You need to have a lot of data. Okay. So machine learning may be classified into supervised, unsupervised learning, and supervised just like we have images with the labels. We are giving the input data with the correct answers. We are feeding the model. These are the apples and the labels we are providing. So after the prediction, it is giving there, yes, it is an apple. But in the unsupervised, we do not have any label. We are just giving the sample of the images or without any label there. But it is trying to identify apples, peaches, or bananas in similar kind of groups clustering. You don't have any input without any correct answer, without any labels. Okay, so that is the difference. Now we can have some how we can define the techniques, different techniques like classification and regression, all these things. So classification means if you see this diagram, the model is learning the decision boundary actually, and what decision boundary is doing, it is separating the categories here. Okay, so blue dots class A I can say, and red dots class B I can say. And can you imagine separating the ripe or unripe apples? That is one kind of problem. Okay, so there may be any any agricultural problem you can take. So if I'm talking about the GIS-based classification, you can talk about the satellite imagery classification. Okay. So forest versus water versus crop versus built up, all these things I have. Okay. So classification is very, very important part. And next, regression. Regression means we are trying to predict on the continuous numerical values. We do not have any labels there. Okay. So blue points here, the data samples, and line means best fit prediction. So model learning the relationship between input features and output value there. Okay. So in the agriculture, what we are doing, we are predicting the yield and we are estimating the soil nitrogen, let's say, or we are forecasting the milk production per cow. That is maybe one example. Okay, so all these things. So regression. Now, if you can see this map, I have put a slide. Then route time estimation actually we are doing distance versus travel time in this. Okay. Now clustering we all know, we are trying to grouping the unlabeled data based on the similarity. Okay, that is the meaning of clustering. And that is two graphic actually, red, blue and green clusters we have, let's say. There are no labels. We are modeling the groups based on the similarity. Okay. The bottom examples you can see that is all about handwritten digits. Okay. And like 7 and 2. So we are grouping by the similarity before any actual labeling. Okay. Next, sequence prediction. Sequence prediction, what we have, what we do, we are trying to handle the ordered data where the past will be affecting the future. Have you heard about the keyword swipe example? The system is predicting the next word based on the sequence of the letters you are using. And what it is using the context, it is using the ordering, not just individual inputs. Okay. So next we can say style transfer. We are trying to transfer the style of one item to another. And this basically introduces Gen AI concept actually. And where the content of the one input is combined with the style of the another. Just remember, content of the one input is combined with the style of the another. Okay. So in the image, you can see a turtle. That is a content which I have. And in the second image, that is some kind of Japanese web painting. And what we are trying to do, the output is a turtle in that wave painting texture, let's say. Okay. So what happens technically, what neural network is doing that, they are extracting the content features from the original image and the style feature from the reference image, and they are recombining using some kind of optimization actually. Okay. So let me ask you some questions. What you will perform on these 5 techniques, recommending what someone will download based on the previous purchase? What could be my answer? That is sequence prediction. Undefined famous landmarks in a photo. What is my answer? I'm doing the classification. Suggesting the spelling corrections. What I am doing? I'm doing the clustering because predicting the quality score. That is the regression. Estimating the arrival time based on the time of the day and traffic. What I am performing? I am performing the regression. Translating between 2 languages. What I am doing? Anyone? Any answer? That is style transfer. So these are the questions which need to be answered. Okay. So these are the applications of machine learning. in the vision, like natural language processing, speech, and robotics, all where we are using the machine learning. So that is the difference between supervised and unsupervised that we talked about, and that reinforcement learning will be focusing now. So just have a look. Have you understood this? So before jumping to reinforcement learning, we need to understand the Gen AI, the importance in agriculture, and people call generative AI Gen AI nowadays. Okay, so Gen AI is not just, we can say, another AI model. It is just like a creative systems. Okay, and traditional AI is basically analyzing the existing data and classifying, predicting, detecting, all these things are doing that we discussed. Okay. Now what Gen AI is doing, Gen AI is creating the new data that never existed. Okay. And images, maps, I can say text, simulations, environmental patterns, all these things. So if you have only 10 photos of rare crop disease, can you train a reliable model? That is my question to you. Only 10. 10 rare crop disease. You have only photos. Then can you train a reliable model? What is your answer? Anyone? What is your answer in that? No. ML need volume. IML need diversity. So Gen AI manufactures realistic new samples. Realistic. Just try to understand this. Realistic new samples. And now data set becomes hundred of times of richer without we are doing any field collection. That is the beauty of Gen AI. So why this creation is critical in the agriculture? Why this creation is critical? Because farmers, they are rarely document the crop disease. They are not doing that. Satellite image may be cloud covered. There are some limitations we have. Soil sampling, if I'm doing that, may be some costly, expensive, or we have some sparse kind of images. Weather stations, they may be unevenly distributed. That may be one problem we have. So Gen AI becomes the data amplifier here. And what type of data Gen AI can generate? That we discussed. Synthetic crop images, synthetic soil patterns, predictive simulations, or text or knowledge generations. So Gen AI basically bridging the gap when the real world data is limited, incomplete, costly, delayed, not available, all these things. So can I say that my agriculture is now AI ready with the Gen AI? Can I say that? So my question is, why agriculture needs Gen AI? That we will discuss. So first, sparse and poor quality data sets. Most Indian farms, they do not digitize the data. There is a problem we have. If I'm talking about the drone surveys, they are very occasional. People are not doing them frequently. They are very occasional. If I'm doing the talking about the sample size are very small, and it may be biased sometimes. Okay, so Let me give you one example. A wheat farmer, suppose I'm talking about the wheat farmer, and it reports rust disease once a year. So that is not enough for a machine learning to learn. So how GenAI is solving this problem? It is producing thousands of realistic images. It is covering that variety, geography, or growth stages, let's say. Next, I'm saying infrequent disease outbreaks. What I mean by that, infrequent disease outbreaks. Because diseases, they are like, maybe sugarcane rot. Have you heard this example? Sugarcane rot. Maybe soybean rust, maybe one example. Okay. So they appear rarely. That is the problem. And due to that, we have insufficient training images. But GenAI can simulate those rare diseases. Okay. Then regional variability, regional variation. So India alone has 20 plus agroclimatic zones. 20 plus agroclimatic zones. Okay. And it is also having different pH ranges also. Okay. So model you can train in Punjab that fails in Tamil Nadu. That is the problem. So now how GenAI is solving that? GenAI basically generating the region specific synthetic soil, or I can say soil plus climate data, both. And it is also enabling transferable models. That is the solution. Transferable models. And last, high cost remote sensing. Satellite images, they have some kind of problems. What problems they have? Because we have paid high resolution data. Okay, clouded. If we have cloud coverage, then it cloud cover blocking optical bands. Okay, that is one kind of problem. Or some temporal gaps are there. Okay, because every 16-day or 20-day revisits are there. Okay, so GenAI may be generating synthetic data which we are talking about. That is cloud free actually. That is cloud free. Okay, and generating if I'm having the images of low resolution, we can do the upscaling of those images with the GenAI. So GenAI is basically removing the dependency on expensive, rare, or unpredictable real world data. Okay. Now, GenAI for the crop disease detection, we can generate synthetic leaf images. Okay. Okay. And have you heard about the GAN, and or diffusion models, and they can produce realistic leaves. Okay, if you go deeper in this, and only 60 images of tomato blight exist, but GenAI creates 6,000 of images. So that is the difference which we are talking about. Okay, if we're talking about the expansion of the data set, then ML basically fails that we talked about, but GenAI can simulate all these things. Okay, because when suppose lighting changes, if you're in the farm, the lighting will be changing, or I can say camera quality is varying from time to time, or I can say some background differences are there. But GenAI is solving all these things. Okay, and this is also preventing the overfitting. This is also preventing the overfitting. Next, I'm talking about the simulate disease progression. This is a game changer actually. How I'm saying that? Can you relate? Because Timeline is very, very important. I mean, if we're talking about a day one, we have a small yellow spot. Let's say we have a small yellow spot. On a day five, I'm having brown patches. And on the day 10, some necrosis is spreading all there. Okay. So what use case? We have early warning systems. We have forecasting severity. We have pesticide scheduling. So farmers can do some kind of action before the risk peaks. Okay. And last, we have low data training. Low data training, that is faster, more accurate disease diagnosis with minimal field data. Can I say that? And overall, what I'm getting, I'm reducing the crop loss. I'm reducing the chemical usage. I'm lowering the, some expert dependency. I do not need that. Okay. Now, generative weather and climate simulation, GenAI used to create high resolution synthetic. So weather is basically deriving 95% of the agricultural decisions. 95%. But weather data is noisy, missing, sparse, delayed, that we talked about. So GenAI can simulate or fill those gaps. Now, if we talk about temperature and humidity patterns, what a use case I can have? I can say I'm predicting the heat stress maybe. On what? On, let's say, wheat flooring. Okay. So your reinforcement learning, what is the role of reinforcement learning here? That try to adjust the ventilation to maintain the ideal humidity overall. That is the role of reinforcement learning. Some rainfall forecast. What we have, it is critical for early evacuation or reservoir management, all these things. Then drought and flood scenarios. Then climate anomaly simulations. So GenAI enables future-aware agriculture. We are not talking about reactive decisions here. We are talking about the future-ready agriculture. Okay. Next, GeoAI. Now, we need to understand what is GenGeoAI. We are talking about GIS plus generative AI. So, have you heard about AI-generated land maps? What GenAI can create? It can create a synthetic land use maps. It can missing the field boundaries. All these things. If we talk about the next forecast, spatial disease overspread. So disease is not random actually. It spreads spatially. Okay. Next, if we talk about the genetic synthetic crop growth models. So different geographies means different growth patterns. Can I say that? So your GenAI basically simulating, let's say, sugarcane maturity under varying rainfall conditions. So this basically supporting the advisory systems or planting the crop calendars if you have. And lastly, if you have geo-aware decision systems, that decisions may be changing when the location matters. Okay. So like some zones may be irrigation prioritized. Some may be fertilizer distribution zones. Some may be pest surveillance routing zones. So that depends on the location also. Okay. So GenAI basically applying the synthetic data, but GIS grounding it into real geography. So together they are useful because we want scalable, we want spatially intelligent agriculture. So that is the use. So when real data is very, very limited, that I just discussed all these things about agriculture, rarely has luxury of nowadays massive or clean data set like ImageNet. If you have heard about ImageNet, some of you might have worked on that. So the problems that can be solved with Gen AI, like Gen AI models, if you name again generative adversarial networks, or some diffusion models like stable diffusion, or I can say variational encoders. Have you heard about VAEs? Those are the models of Gen AI. Okay, so let me give you one example. Imagine only 40 images you have. So Gen AI generating 5,000 synthetic variations. And what synthetic, if I'm talking about the variations, what variations I have? Different lighting, different leaf angles, different severity levels I have, or humidity based some appearances changes. What we are talking about the variation, that is important. Now, if we talk about a scenario simulation, proactive choices based on what if crop. Because traditionally ML, they are learning only from the past data. But Gen AI, you are allowing you to create futures that not happened yet. So what if scenario may be included? Like, what if the rainfall is dropping by 40% in week 6 of the crop cycle? What you will do? What if the locust uh, activity increases due to temperature rise? What you will do? So these kind of answers may be given. So these simulations may be helping you to, what are the users here? Agricultural planners, उनको help करेगा. Seed companies, policy makers, all may be getting benefited from that. Now, if we're talking about the cross-domain transfer, just like human use, we use X-rays, we use MRI, CT scans, all these things. So plants can also be benefited from thermal imaging, let's suppose, or I can say hyperspectral imaging, if you have heard, all these things. So what Gen AI can transfer from the medical AI? That answer may be given. Okay, so this is all about, we can discuss. If we talk about the parallelity between humans and crops, because if you're talking about the human healthcare, like MRI and X-rays, they detect disease early. In the agricultural, we can say leaf scans, they detecting the infections early. So we are trying to combine that. Okay. So reinforcement learning now for the crop sustainability, that is very, very important. And to cut down the waste, we are using the RL agents. They choose when and how much to irrigate. Scheduling of the pesticide, that can be the task which reinforcement learning can perform. Okay, so all these things we discussed. Now, if we talk about the holistic healthcare, humans plus crops, we talked about. So unified vision is AI promoting the sustainable agriculture and healthy people, both. So nowadays we are talking about the humans plus crop, holistic healthcare, not just agricultural health. Okay. So now we talk about reinforcement learning. How it is working. We need to understand how actually it is, what it is, and how we can involve the algorithm in the agricultural field. So in the reinforcement learning, we have some agent that is decision maker, that need to take the decision. It could be any robotic arm maybe, who is trying to decide how to grasp a particular fruit, or it may be some drone monitoring the agricultural fields, or it may be some software system which is scheduling the irrigation of that farm. So agent is important in the reinforcement learning. and agent is taking the actions and improving over the time. So next we are talking about, so first we need to understand that agent is trying to interact. Just if you have heard this dog master example, what if you get a new puppy, initially he do not know anything and you're trying to give the commands, and slowly by the experience and learning he understand that by following this command I'm getting the reward, by following this command I'm getting the penalties. So learning purely through experience. First time what is trying to explore all, try out new commands and paths, and then slowly when the policy is involved and it is built, then it's learn that if I'm sitting that I'm getting the reward of this +1 or +2 or some treat. So that is the reinforcement learning. So I was talking about this agent and environment. So what environment, what is the meaning of environment? Because the world the agent interacting with, जिससे भी interact कर रहे हैं, the observations, the rewards, all these done by the environment. So what environment I can imagine in the agriculture? Let's say a field with the changing moisture, I can say, or a traffic junction, maybe if you see, that may be the environment. So environment, the agent is all about interacting with all kind of components that comes into the environment. State means the current situation of the agent. What is the current situation of the agent in the environment? Okay. So if I'm talking about the agriculture, the soil moistening level, that may be the current situation. Or crop stage, time of the day, this may be the current state. If the state is incomplete, then I can take optimal decision? Can you give me this answer? So that has to be optimally defined. Next action, the choices we have, the possible moves the agent can take, like I can turn irrigation on, off, low, high. These kind of actions are possible. I can apply pesticide today, or I can wait, I can increase, I can decrease the dosage. That might be the action. Then reward. Reward means the feedback signal, not the goal itself. I'm talking about the feedback signal. It may be positive, it may be negative. If you are doing the good outcome, if you are expecting good outcome, that may be the reward. And if undesirable outcome, it may be negative. Okay. So if you are reducing the crop water use, let's say without any yield loss, so you are getting +20 for it. So that may be the reward. Okay. Next, policy be defined by pi, the strategy used by the agent. That is the policy. Okay. Next, value function. Value function means the estimating the long-term reward from a state. How good it is to be there. That is the answer given by this value function. Then Q function, this is estimating the value of state action pair. Okay. If I am action A in some state S, how good will it be in the later stage? So that's the answer given. So discount factor, that is the important term. Discount factor, what does it do? It basically balancing the short-term rewards and future long-term rewards. Next, exploration, trying out some new actions. And exploitation means we are using the best known actions. Now, let me ask you one question. If a farmer only focuses on today's yield, then what will be happening in the next season? That answer will be given by discount factor. Okay. So this is the things we discussed. Now, this may be one simple example is navigation of the image. The image showing a robot, diamond, and fire. I'm taking a simple example. You can imagine an agricultural field also. And the robot is trying to learning by trying all possible paths initially. And then it is choosing the path that giving him the reward with the least hurdles. And each right step will give the robot a reward, and each wrong step will subtract the reward. that just like problem can be defined. I can discuss another problem. We have a robot vacuum cleaner that has to clean the entire room while avoiding the obstacles like walls, furnitures. And the agent, the vacuum cleaner, is supposed to find the best path to cover all dirty spots. That's maybe one kind of example. Okay. So now we are talking about model free and model based. What those kind of methods are there? In the model free, the agent does not try to understand how actually the environment is working. It simply take actions. It observe the path or observe the results, whatever it is getting, and improving the policy over the time. So we have policy-based methods, we have value-based methods. Policy-based methods may be directly optimizing the policy pie, which I was discussing earlier. And it is actually useful in the continuous action spaces. Or I can say robotics with the smooth control. Those kind of things. Like reinforce, like actor critic, like PPO, these kind of algorithms. If I'm talking about the value-based methods, that is learning how valuable an action is in a particular state, like Q-learning and deep Q-learning methods. Now, if we talk about the model-based, the agent learning a model of how states changing, what rewards will result. All this initially they are learning. And that model may be used to plan the actions ahead. Okay. So model free means reacting. Model based means thinking ahead. That may be the difference. Okay. So that is the key difference which you can understand. I mean, these are applications which you can use, how when model free may be using, when model based will be using, that you need to understand. Okay. So selection is very, very important. If you, if you need data need, if you have less data, that model free may be the high choice. That is the best choice. Okay. If you're talking about a safety concern, that model based may be more safer. So you need to decide. Okay. Now, process of RL is very, very important. We need to understand that if I'm talking about this block, S8 basically a obstacle in the red color, S6 may be some solid wall where movement is not possible, and S4 in the blue, that is the outcome. So if I'm reaching that, I'm getting the reward +1. So let me take one path from S9 to S5, S5 to S1, S1 to S2, S2 to S3. So in this example, you see wherever the agent is completing one episode, completing one path to final goal, that is S4. It is assigning the value of each block 1 to remember it. But when it, let's suppose it want to try out new path from S1 or S5, then it is seeing the value of both the blocks is 1 on the either sides. So it cannot take decisions which block value is better, which path is better, because every value is 1. So that problem can be solved with Bellman equation. In the Bellman equation, I'm using this formula, and that formula Vs is the value at the current state, Rs is the reward, alpha may be the, gamma will be the discount factor, 0.9 that we talk about the long-term rewards, and V of S dash means value at the next state. So if I'm applying this formula, I'm getting the different unique values. So now I can decide whichever value is higher, that is leading to the closer to the goal with the highest reward. Okay. So that may be the answer, unique values I'm getting. Now we need to understand the MDP. MDP is a mathematical framework that is used used for the modeling decision-making problems when outcomes are partially random and partially controllable. Okay. So if the reward is only maximizing the flow, what unintended behaviors may appear? That is my question to you. And that is solved by MDP actually. Okay. So let's say a system is receiving the sensor-based data, traffic lights having some finite actions. These kind of examples may be solved with MDP. Okay. So now what happens if all the roads given equal priority? क्या होगा? Should emergency vehicles change the reward function? Or what other cities already use adaptive traffic control? These kind of answers may be given with this MDP. Okay. So in the Markov decision process, a set of possible states, maybe infinite, a static state we have, a set of possible actions, a real value reward function, a transition function we have. Okay. So if we talk about the example, managing intersection delay, have you think about the waiting time at the traffic section? What we have, we want to do better minimize the waiting time at the traffic light. And we want to have maximum number of cars passed in that waiting time. So that is my problem. And that problem can be mapped with Markov decision process, MDP. Okay. So I will discuss some value-based algorithm here, the Q-learning and deep Q-learning. And I talked about that the value of V as does. If a state value is higher, it means that state must be given the higher preference. Okay. So to estimate the Q value without storing a table, that is my answer. And to generalize across massive state space, that is one question. So in the Q function, what I am doing, I am using this value, this formula QSA equal to QSA. QSA means I'm trying to find the new knowledge, and that QSA means the old knowledge, and the later part I am having what alpha means the learning rate, what new information I have added. RSA means the reward, and gamma means the discount factor, all these things. Okay. So this formula can be applied. This we term this formula is temporal difference, and it is basically the difference between the current estimate and the expected discounted return. Okay. So I will give you one example. Suppose you are a mouse in a tiny maze and your goal is to eat the big pile of cheese at the bottom right hand corner. And if your episode will be ending if you eating the poison, if you eating the big pile of cheese, or if you are taking more than 5 steps. Now alpha and gamma is already defined, 0.1 and 0.99. These are the reward function you need to get. आपने बना दिया कि +0 इसके लिए होगा +1 +10 +10 as per your problem. Now initially you need to in the Q table, in the Q learning, you need to maintain a Q table where and the one side you having all possible states, on the right on the column side you have all possible actions, and initially all values are 0. And now you are performing an action, let's suppose write from the first state, and you are taking this formula, you are applying the Q learning formula which I talked about, and you are getting the value of 0.1 like that. So you have updated the value for one state action pair. Now you need to update the state action pair for all possible states. Next, if you are taking next action, you are getting the value -1 here. So like that, you are keep on updating. You are trying to get the value of every state action pair in the Q table. So that is the solution. Just like another example, I have 5 states, S1, S2, S3, S4, S5. So left, right, up and down, 4 actions are possible. I need to update the value wherever 0 is there. I need to update every state action pair in this Q table. I will apply the formula. All value I have, I will getting, if I'm moving S2 to right, if you can see in this diagram, from S2 to right, I am reaching to the goal state. I am getting the 100 value. Like this, I am from S5 to up, I am getting 100 value. So like this, I can update, and lastly, I am getting this table. The now question is when I will stop until I am getting the optimal policy. I need to continue the process till it converges to optimal policy. Okay. So training consists a series of episodes. Okay. Now question is Q learning sufficient? when we use DQN. So historical context की अगर मैं बात करूं, it was introduced by DeepMind in 2015. Okay, and it is learned to play the Atari games, if you have heard about, directly from the raw pixels. Okay. So why was this a big deal at that time? Because computers, they learn the complex behavior simply by observing the screens, not by being told what objects are actually are. So if we talk about the key components, we have neural network. Deep network take state as input and output Q value for all actions. We have neural network here. We do not have any Q table here. And experience relay means in standard online learning, if you see consecutive experiences, they are correlated. So neural networks require that independent samples. That's why we're using it. And if we talk about the target networks, network is learning and evaluating itself with its own changing predictions, let's say. So it leads to instability, it leads to oscillation, and the solution is to maintain a second copy of network that we call it target network. And we update this every k step, let's suppose. Some k will be the hyperparameter. So that is the solution. Okay. So basically the difference is we have the experience relay and target network. And if we talk about the experience relay, it's just like a buffer. That is not just storage, it is the training data engine we are talking about. Now, let me ask you one question. Why can we sample from the past in reinforcement learning? But humans can't replay old experiences exactly. Okay. So more stable learning, if I'm talking about, I need experience relay because it's breaking the correlation. I'm talking about the target network because it is stabilizing the value estimation. Okay. So different application area, you may be the audience of different backgrounds, and reinforcement learning can be applied in various like healthcare, finance, evidence system, all these things. So let me highlight one research problem which I have worked in from the past 3 or 4 years, so 5 years maybe. The motivation is, I mean, I'm using the smart and secure sensor charging scheduling actually. And if you talk about the thing, I mean, the modern agriculture is no longer the guesswork. It runs on the data actually. So sensor fusions, sensors maybe monitoring all environmental conditions, and decisions become reactive, not proactive, and we need to do that. So it has to energy requirement because sensors battery is very, very small. Sensors are only useful when it is continuously operational. So how to give the supply? By mobile chargers, you can give the supply. Drones, by drones. Manual battery replacing is not possible actually. Okay. So challenge is geographical scale. That is one kind of challenge. Time bearing needs, environmental uncertainty that we talked about in the previous slides. Scheduling dilemma, when to schedule, because sensor may be unevenly distributed. That may be the large network, and at the same time you have multiple requests. So what kind of solution you can propose? Because you can propose what my problem is look like. We have a functional wireless rechargeable sensor network. We have a number of rechargeable nodes or one or more mobile chargers. And the problem is, what should be the order of charging the nodes? In which schedule I need to charge them so that all getting the energy replacement in time? That is my question. So this is one kind of area. So that research problem can be mapped with reinforcement learning. Okay. So that is one kind of solution by the decision making. Okay. So if we talk about the future research direction, some multi-agent reinforcement learning we are talking nowadays because multi-agent they learning simultaneously in a shared environment. Then explainable and interpretable RL we have. Okay. Then integration with the other paradigm. We can combine it in reinforcement learning with supervised or transfer learning or meta learning nowadays. And quantum computing and climate modeling, all these real application may be clubbed with this reinforcement learning. Okay. So this is the reference. And lastly, one example of, for your reference, I put in, if you, the goal of the agent is to maximize the total reward accumulates over a fixed number of steps. The random module I'm using because I need random package. I want to randomly select actions. Next, I'm defining the environment class. Then I need to initialize the environment because environment is starting the 20 steps, and I need to keep a check until all the steps may be computed. If it is not computed, I need to repeat it until all the steps are over. Then I need to get the current observation, what actions we have, what environment I have. Then I need to check. Then I need to perform that action. Every time I am performing action, your step will be decreased by 1. Lastly, I am defining the agent class, then initialize the init because I need to initialize it, and then agent taking the step, and I'm printing it because I need to print what actions current observation I'm printing, and I need to keep a check whether the total number of reward is added to the maximum cumulative reward or not, because for every action I'm getting some reward. I need to keep a sum of these, and lastly I'm getting the maximum reward that I need to get. Okay, so every time I'm taking steps, step will be increased by 1 and total number of reward will be added, and lastly I'm printing that total reward. So this may be looking like this. This I'm getting over a series of episodes. Okay, so this is the one kind of link I have put in for you. Is had 2 problem like match problem and game within finite steps. So thank you for today being a wonderful audience. If you have any questions, you may ask. And if you want to collaborate on, these topics, you can connect me anytime. This is my research lab that is named Ascent, Algorithms for Smart Computing, Energy, Network, and Task. And these are my profiles. You can connect anytime. I will be happy to collaborate. Thank you.
Thank you, sir, for your very informative session. But before this, audience, please, if you have any question, please ask. Please raise your hand if you have any question.
Sir, there are some questions in a chat box, sir.
Yes, one of the question, Abhinav sir, there is a question in the chat box. That is how to identify the balance between training data and test data while training in validation dataset domain.
Sorry. Yeah.
Yeah, Abhinav sir. So there is a question in the chat box which is already given by one of the participants. That is how to identify the balance between training data and test data while training in validation dataset domain.
Okay, so if you want to, have a balance, you need to understand the purpose of split actually, training set and testing set. Okay, training basically doing the fitting the model, and validation we want to tuning the hyperparameters. So validation is not equal to test. Okay, so for the normal data set, we have 70, 50, 50 rule, 15, 15 rule, 70% training, 50% validation, 15% test. But this is not universal because data is very, very limited you are talking about. So you can have 60, 20, 20 rule in that case, 60% training, 20% validation, 20% test, because you need to prevent the overfitting on smaller data sets. Okay, so you can use k-fold cross validation if you have it. Like if I'm using 5-fold CB, so 80% of the training and 20% of the validation per fold I can use. Or I can use domain shift validation or scenario. That may be the answer.
Okay, thank you, sir. There is one again question by one of the participants, Pooja Meena, that in reinforcement learning, how to train agents.
So that is done by, they are learning from the experience actually, which I talked about. If you need to define your problem first, and then you need to understand. Because a RL agent learning by taking an action, then it is trying to observing the state, then receiving a reward, and based on the reward, it is updating the decision-making strategy. So first you need to initialize it, then you need to interact, choosing a state, then you need to apply the formulas, and then exploration agent will do. And it is learning and repeating the step until it is getting to the converging state. So if I'm talking about a different training settings, maybe episodic training or continuous training, anyone you can use. Okay.
Okay, sir. Thank you. Sir, here one last question. There is always a issue of trustworthiness. So how to create a trustworthy model for farmers? Uh, because the results generated by AI models are always under the question of trustworthiness.
Okay. So, I mean, that is very, very important question. I mean, um, because trustworthiness is we need to deal with this very, very crucially actually. So, what I mean, how can we summarize in maybe because technically reliable and trustworthy of farmers we are talking about because what we need to so if I can say start from the decision support, not the decision replacement if I'm talking about. So in the farmer language, if I'm talking about for each prediction, we need to show the top factors. We are influencing it. I mean, soil moisture is low in your top field, or I'm talking about the weather forecast. So have you heard about the SHAP or feature importance internally? But surface are basically simpling, bulleted points. So showing the uncertainty honestly, that is one kind of solution because overconfident AI may be killing the trust. So instead of binary outputs, you can show, risk levels are there and confidence bands are there. You can use those things. So you need to design conservative and safety first policies. Like if you're talking about the irrigation, so I can suggest you some slightly conservative water savings. That will be gradually tightened or as the confidence will be growing day by day. Or I can use some reward shaping if I'm using a reinforcement learning that perspective. Okay. So
Sure.
that may be my answer.
Okay. Thank you, sir. So audience, any other question? Okay. Thank you, sir, for your such a wonderful session. Now I invite Head Civil Department Dr. Manoj Sharma to propose vote of thanks.
Thank you, sir. I am audible.
Yes, sir, you are.
On behalf of the organizing committee, I would like to express my sincere gratitude to our esteemed speaker, Dr. Abhinav Tomar, Assistant Professor, NSUT, Delhi, for his insightful presentation on the application of reinforcement learning and Gen AI in smart agriculture. Your deep knowledge and engaging discussion on how this technology are revolutionizing farming practice, optimizing resource use, and enhancing sustainability have greatly enriched our understanding. We truly appreciate the practical example you shared, which will inspire us in our future research and development effort. We sincerely appreciate your time, dedications, and inspiring contribution. Thank you, sir.
Thank you. Thank you
you.
so much. Thank you so much for giving
you,
me the
sir.
opportunity. And I hope audience will be have learned something and they will use it in future research endeavors. Thank you.
Thank you, Abhinav,
Thank
sir.
you, Abhinav sir. Thank you.
Thank you. Thank you.
So,
Audience,
Abhi sir,
yes.
Mr. Abhishek Kulshrestha is already in. So
Okay.
let's welcome him. And
Definitely.
Hello, everyone.
Abhi sir,
Hello,
welcome sir.
Abhishek,
Welcome.
sir.
Good evening, sir.
Hi, this is Abhishek from Bhopal. Yeah.
Sushil sir, please make him host. Abhishek Kulshrestha sir.
Okay. Do you want me to share?
Yes, sir. Sir, I just make you. Yes, now you are co-host. So before
Okay.
moving to that, I just announce something to our audience. So, audience, yes. Now, participants, good evening, everyone. Once again, now we will proceed for our next session. I invite Mr. Abhishek Kulshrestha, founder, Flairsoft Consulting Group, to deliver his talk on AI and human intelligence, collaboration or competition. It's my absolute privilege to welcome Abhishek Kulshrestha, the visionary founder of Flairsoft Consulting Group, Bhopal. Mr. Kulshrestha has played a vital role in establishing FCG, a global software solutions center that supports clients across the world while leveraging best-in-class people, processes, and technologies. Under his leadership, FCG has become synonymous with highly quality, highly valued software development and support services. with core strengths in software engineering, business process management, mobile development, and geospatial information services. With over 15 years of robust experience, Mr. Kulshrestha has successfully managed offshore centers, leading a team of more than 80 professionals. His expertise spans across day-to-day operation management, product development, mobile solution, consulting recruitments, product lifecycle, and many more. One of his remarkable contributions has been made in the development of web-enabled right-of-way and real estate management solution, integrating all aspects of land acquisition, asset management, and right-of-way processes, an innovation that has set new benchmark in the industry. Beyond technology, Mr. Kulshrestha is a strategic partner in talent acquisition and leadership development, fostering a culture of performance orientation, aligning HR processes with business goals, and nurturing the next generation of leaders. So now it's time for our honorable speaker, Mr. Abhishek Kulshrestha. It's over to you, sir.
Thank you for giving this chance, and I give credit to all the organizing committee for giving this. Though we are in a software domain, I think my target audience is all computer science IT. So I align is all computer science, or we have a mix of students? Just wanted to ask Raju. Is it all?
Faculties maybe from the variety of backgrounds.
Okay,
Uh,
okay.
Yes, sir. Yes, sir. But major of the faculties are from the technical computer science background.
Okay,
IT
okay.
background.
So I think they have a deep knowledge. I think I have covered in a very simple language what is like everybody knows AI. Like if my screen is visible to you?
Yes,
My
sir.
Yes,
slide
sir.
deck. Okay, okay. So yeah, this is what we are building. Actually, we just to give a small introduction, we are building a land acquisition softwares for US and Canada. So we expertise in the domain of land acquisition. Wherever any infrastructure is being laid, be it a gas pipeline, be it a road, be it electric networks, our solution come into the picture for acquiring the land rights. So I started my journey in 2009 as a computer science expert and with Cognizant, and there I worked on their SaaS and cloud computing solutions. And as you all have seen, like the buzzwords for today is all AI, right? But we need to understand at the deep level what is really AI, like AI and machine learning. Everybody talks about it, but implementation, like there is a huge gap, what I can sense in the implementation, like coming from a west to coming from here. So a lot of things. So I will be covering very basic level. I think everybody is into CSIT domain, right? Right. So I align my content to that. Or we have some a mix. Just wanted to ensure that. Raju, everybody is from computer science IT or?
Yes, sir. But it's a mix of the folks, sir.
Okay, okay. So yeah, this is what like AI is all which is artificial, and human intelligence come where human decision making is informed. Okay, so I'll share a AI perspective and a human intelligence perspective and FCG what we are doing in that, right? So this is the first slide that I am. So introduction to AI. AI simulates human-like thinking, right? Using data and algorithms. And three types of I categorize it as a narrow, general, and super. So narrow is when you just automate redundant task, and general is more like we call it AGI with what ChatGPT is doing, and super is what we are trying to achieve with more than human intelligence. So super AI. And what AI does, so we are implementing at the FCG level in right of way and digital transformation projects. So our solution for land capturing, we are implementing AI for training our machine learning and the data sets that we are doing with large land parcels, and we are then automating all the tasks. Okay. Now coming to human intelligence, you know it is all about emotional, intuitive, and creative, right? Wherever the brain is involved, it is all human intelligence. And that's the reason, like I'll say we are above the AI right now. It is just the redundant thing that we can automate right now with AI. But AI needs a lot of data sets for getting trained. So that's what complements. We are doing it in governance and also in US for that. And key differentiators that I can see that AI comes when there is a speed, scale, and memory. So AI comes into the picture for that, and wherever empathy, ethics, and critical problem solvings, that's the human interface we can talk about. And FCG level, what we are doing both, like a mix of AI plus human intelligence. So all our core developers, they use all the Copilot and all that, but still we are implementing more on the human levels more. So all the code base that we are building is with the human intelligence only right now, but I think I can foresee with all the vibe coding coming, we are going to have all the code base be written by our machines also soon, what we can sense in the near future. So right, and hybrid model is what that. So in the terms of collaboration or competition is that is given to me. I'll think AI is more like collaboration is the key to the success as of now. So having this debate like is human intelligence more or is artificial intelligence more is not at this moment. I think we are at a very nascent stage, and I think the collaboration what we need right now on the between the AI and the human intelligence. So all our right now programming happens through human intelligence only, but as long as the models are getting trained and pretty soon we can expect AI to be an augmenter to us in terms of programming and building the development of apps. Okay? Do you have to ask questions simultaneously or we have a separate round? So Raju?
Sir, we have separate round for this.
Okay. And now coming, I have made it at a very general level. Like I think if you all are faculty, you might be having deep note, but it's like what I am while implementing my solutions, what is the very basic at AI and what are the basic at human intelligence. So
Oh,
coming to strength of AI is you all know, like all the models and like high accuracy, scalability, 24/7 and data driven. And coming to strength, like we can solve any complex problem, ethical judgment, and emotion. I think emotion is the biggest thing that separates human from the artificial world. So this is at the root level. Okay, and now I see where AI excels. Now, what is the main thing where artificial intelligence come and it's all about automation. One word is automation and analytics and predictions, pattern recognition and operational efficiency. What we are seeing it with this Microsoft Copilot or Claude or maybe Anthropic or every company is that they're all are augmented to us. Like I'll accept that AI is the biggest enabler that a computer science folks can had. So it helps us whatever the prompts we are making, whatever it gives a very good output. But somehow in our case, in our development patterns, it sometimes got weird results also. But it helps us a lot. All the developer community, as you think. Is getting towards vibe coding. Every prompts that we are making and we are taking machine help for doing that. And now comes the area where human excel is innovation and leadership. Like AI cannot do anything on its own. It needs input and output for getting things done, right? And complex decision making, wherever it comes, it needs a human interface to do that. And handling, yes, emotions and uncertainty, right? And coming to a collaborative, like this, what I can sense, like the future belongs to healthcare, all these industry, energy and utilities. And what we are doing for US government right now is governance workflows. All their workflows that are right now, we are pitching them to automate all their tasks, which are right now manual, and we are putting a system towards it in the area of land acquisition. So our specialty is right of way management with AI. So FlareDocs is very key enabler in that. Our product name is called FlareDocs, and we are just pushing everything towards the automation stage. And like development is also very easy, and deployment also is very easy now. Post AI era. Like I think in healthcare, yeah, partner or rival, it's up to your perception. But yeah, AI does help in all the diagnosis, all the ethical decisions. And yeah, we are working on a POC of few American governments for their AI implementation in their healthcare system. Coming to, yeah, AI, I think education is the most impacted field. I think there is a big debate right now, but it's very good enabler. Like if you are a self learner, I think AI can be a very good augmenter to that. So you have personalized learning, then teachers also get augmented, and then we have AI driven assessments also. Coming to AI in business, yeah, that is the biggest thing where we are pitching all our revenues. All our revenues are towards process automation right now in the US, and every client wants a smart dashboard and insight. And we use AI to optimize all our government operations right now. And we are doing a very good pilot for 2, 3 big land management companies also. And we recently deployed 2, 3 systems for them, right? And yeah, AI in the government, it's all like emerging as of now. I don't know where the domestic market is heading, but US is really pitching a lot towards the automation of every process. So we have huge potential and scope back there in the West world. Okay, and yeah, I might be fast, but then we can. I have 1.5 hour, right, Raju?
Yes,
How
sir.
much time?
Yes, sir.
Yes.
Yes.
Okay. So yeah, ethical concerns, yeah, there are get lost with AI. There is a lot of biasness and misuse also, and there is a risk with AI. But yeah, we as the models are getting trained, they are getting smarter also. Now, future skills, I'll say that we need right now is the AI literacy and digital. Like I think the most important word right now is the awareness. Like we all listen to AI, but I think implementation is the main thing where we have to upskill. So only one word I have to tell, like to all the teaching community as well as to the student community, is that we have to upskill on daily basis. Every model is getting changes, everything is getting changed. So that's the biggest thing. Like upskilling is the most important. Even we have given co-pilot licenses to our people in the company, and every day new models are emerging and they are implementing new things over it. Now coming to the most important question, like I think my view or my point of view, AI can never replace a job. matlab it can just all the redundant tasks can be automated, but it needs a human interface right now. So this is the main thing. So new roles will emerge, and I think the biggest landscape that we can see in the area of AI is the prompt engineering. We are training all our resources right now towards building complex prompts and making modules by prompts itself. So this is the most important thing we are foreseeing right now. And yeah, we are all the workforce is being trained in the AI digital space right now that we have. And mostly towards the Microsoft stack, we use Copilot licenses have been given to all, and integrating in our code base right now. So this is the main model that we need, human plus AI synergy. So AI is the efficiency and human is the creativity, I'll say here. And everything that we are building right now needs both. AI also is needed and human intelligence also needed for building very complex tasks right now. And yeah, hybrid systems, so that's I always vouch for. So that's what. And we are also like making adopt a human in the loop AI. So everything that we do with AI, we have a person who kind of foresee everything in the AI outputs that we have. And all our code commits right now is managed by human interface only. Nothing is automated there. All the all the code that we are submitting, all the pull push requests to the Git is all maintained by human only. So we are implementing AI right now, but everything is human controlled only. So it is just augmented right now. So the future of the intelligence, I think the rise of hybrid. So hybrid here, both human plus AI. and we think AI should be a collaborator. It's just to help you. Like, it is not there for competition. So whenever AI comes into, it will only help you. Like computer science folks, they will get huge benefit out of it. So coming to the topic, that as a collaborator or competition, AI will only help you. So it will help you a lot. And like in case, everything right now, what we are implementing, we are just taking hints, or maybe better outputs to optimize our solution. But everything is in human context only right now, because the systems that we are building reach large data set of land. So in that context, I'll say it's collaboration is greater than competition. So that is my 2 cents on the AI and the human. And conclusion, yeah, AI and human are partners, so they should never be in a competitive landscape. They should always be our partners. AI will only help all the engineers or emerging tech right now, what we are implementing. And collaboration is greater than competition, like what I foresee. So that's what I foresee as a product development company here in Bhopal, making land acquisition softwares. And AI, India has a huge potential right now. Whatever I portrayed is more towards the west, because my geography target area is west, is the US only. But India has a very huge potential. But making all these GPUs and investing all these is will take little time. But yeah, it will eventually come in India. We are making our own AI stack also. Sambhav is, I think you might have heard of. So we are doing everything to have a good AI infrastructure soon. And NVIDIA is the main, I think, behind all that. So that's I wanted to cover. And if I have a faculty domain, like if I'm open for any questions, or they have in like implementing what we are doing.
So audience, if you have any question, please ask.
Otherwise, I can guide you about what we do in Bhopal. We are a team of 90 members, and we are implementing land acquisition. FlareDocs is the name of our product. So I can give you a little overview what we do.
Yes, sir. It would be good for us.
Like, so let me just open mail. So we build. My screen is visible?
Yes, yeah.
So this is what we are founded in 2001 in the US. We are a team of more than 100 people, and in US, and like FCG is the Indian entity. We are like a GCC here in Bhopal. So Flaresoft is our parent company, and we are 100% export oriented with good annual growth. And we are providing good IT products and services to US and Canadian clients right now. And we are registered with STPI. We have our office in STPI Bhopal. And in the US landscape, we are like in India, we are based in Bhopal only. And in US, we are targeting almost each state we are having a client. And these are our clients, which are like big gas pipeline, electric companies that we are building solutions for. Is it visible, my PPT?
Yes, it is, sir.
Okay. So on a high level, these are our products that we are building. So suppose transportation department for gas pipeline, for local, for utilities, and for renewable. We are building these solutions. So DOT track is the main product that we are building, and we are investing highly in our land acquisition for road construction. So FlareDocs come into the picture wherever any land acquisition happens, and our solution helps them in managing the land rights and infrastructure. So we have a kind of a low code, no code BPM also. Like as you imagine, all the software development is going towards less coding, and it is more customization and configuration. So our solution out of the box is more about configuration now. So these are some of our processes that we are integrating and automating. So all the route selection, because as you know, land acquisition comes for all these modules. Like it will take at least 3-4 hours to get into the
Excuse me,
detail.
Abhishek sir.
Yeah,
Sir, is slides so, matlab, can we run through the slides too?
yeah. This?
That will be better for busy. Yes, sir.
Okay. So this is our application that we are building. So suppose you want to build road and you have to acquire the land rights. So our solution come into visualizing. So you can at least visualize what we are building, right? Wherever, kahin pe bhi, if we have to build a road, so or gas pipeline or electric utilities, our solution come into managing the land data, land parcel, and giving all permits. So basically, it's a permit management system to the government and all the route planning system also to the key vendors. So like we have a workflow automator. So all these workflows are automated right now. So these kind of business intelligence and data analytics happens. कितने हमें, just suppose on a high level, if we want to construct a road, how many properties are there? How many parcels are there? How many landowners are there? So all this happens through our solution, which is called FlareDocs. These are our modules. We have a mobile app also on Android and iOS, right? So it's BPM, but everything towards now getting into AI ML ready transitioning. Also, if you can see, it's everybody client wants AI ML capabilities and generative AI capabilities in it. So we are integrating, but it is at a very nascent stage because we have a journey of more than 2 decades right now. So we are slowly implementing all the AI modules, but still 70% of the workflows right now that we have, it's more manual, but we have a aim to automate everything. So these are the AI ML key uses that we have. Like we have like use cases right now. If you can say intelligent document management, virtual assistant, risk mitigation management, and mission success. So all these like what we are doing right now in the AI ML space. So a chatbot, NLP, a transformer, and algorithm based, right? So Flarebot is this. Like if you can see Flarebot, you can ask your question. So it's a generative AI, and FlareDocs gives you answer to their queries, whatever they want. So it is all in the context of land acquisition right now. So Bhumi Adhikaran, as you say. So we are pioneers in that system, and we are giving good systems to US government right now. So document digitization, this is one of the IntelliDoc module that we are doing. It requires very vast amount of data sets training and template tagging and all those we are right now doing. So it's a complex, like all the records, all the document generation happen through our solution. So that's a very high level picture of our IntelliDoc that we are building. So I think getting into details will require a lot of time, but I'm just giving you a very high level overview what we are doing. So this we developed for Manet, so that's why I think few slides are there for Manet. We have a good collaboration with the MNIT Bhopal. So what we are doing right now for in the product development and in the support services that we need. So we are very few companies in the Bhopal that works on GIS stack. So geographical information. So we are partner to ASRI and we are building those solutions. So yeah, that's from that perspective. So
Okay.
now I take your questions.
Okay, Abhishek sir, sorry, Abhishek ji, there is already a question in the chat box that it is asked that emotional intelligence can ever be replicated or understood by AI systems?
Do you think? I don't think so. There might be sensors or they might develop it is a very research question right now because I'm more not towards the research side, but yeah, I think we can emulate right now, but I think we can never be like human intelligent. Machine needs an input and output. So if you give a feed point, and then if you expect output, it might can replicate, but it can never have its intelligence on its own. Like, I think so. My perspective, but I have to deep down. It's more like a cognitive question. So what
Sir,
kind? But yeah, human intelligence, like emotions, machines are not able to replicate because like it's a non-living thing. But yeah, if 10 years might be you have sensors or something coming which might emulate some behavior, but it will be artificial only. Like my 2 cents here will be it will whatever machine generates, it's artificial, whatever human that is natural. So yeah, we can emulate that, but I don't think so. We can always replicate same tendency because machine all depends on I/O, input and output.
okay,
So
sir.
yeah, so AI helps smart parking systems.
Yeah, sir.
Okay.
This is basically need of India also
Yes,
these
yes,
days.
yes.
That's why. Is it
Yeah.
any task or any work happened in US or in India?
There
If you
might be
can throw
systems,
any
but
light.
I might have to explore since I'm not from that domain. But parking, I also feel it's one of the biggest challenges in India, and we need smart solutions. But I think what these companies like Tesla, BYD are doing right now, but even they are not 100% efficient. They need lot of training data sets and but there is a one company, Swast Robots in Bhopal, that is doing very good towards that. So I might invite them for some sessions. They are doing very good. They have, you might have heard of a news. They have automated a Bolero with their system, and it has very good results. But yes, I think in long term, as the machines are getting mature, their models are getting mature, we might have a good. But right now it's pain. Even I feel whenever I have to go somewhere, parking is one of the
Definitely.
biggest. So somebody asked me what are our biggest challenges,
Yes.
right? In land acquisition in the US, because our challenges come from our vendors. We are basically a tech enabler. So we give the software to the agency, and then this agency has. So the biggest tech implementation wise, you are asking, or you are asking at the process level? Who, Dr. Anand?
Sir, tech implementation wise, since the topic is
Okay.
related to AI.
Okay. Tech implementation wise, yeah, AI engineers it's I mean, we don't have competent right now AI engineering team, but we are building that in US because all our data sets and all the things are happening in US. We still don't have a AI ML branch in India office because everything and one constraint we have while working with US government, they don't allow any data set to go out of US geography. So that is one of the biggest. So we have to work on dummy and test data only. They don't give their real data outside UHS. So everything that is happening in AI ML space right now is taken care by US office because in their data sets they are exposed to that. So that is our like data sets is the biggest challenge which we don't have. So what skill
Okay.
sets should student I think, as you know, skill sets, I think in terms of basic, still the fundamentals remain the same. I think in developing, we need very strong OOPS, DBMS, data structure, problem solving, and all that. But in AI, like even I am also learning day by day. So it's emerging right now, but I think where we lack is the implementation part. I think hardware wise also we don't have the environment. Like as somebody said, our biggest challenge right now is that we don't have an environment locally in India office. US office does have their infrastructure because it is very the hardware cost is very high, and the all the servers and the machines and the GPUs that you have to invest in is very high. So right now, even we are struggling, but we do have an instance in the US environment, which is like on a test data, not on real data. But yeah, hardware wise, we lack a lot in India. So that is our challenge, and like cost factor also rises a lot when implementing solutions towards that. Well, IntelliDoc, one of the system that we are building, has a lot of potential, but when it comes to data, the data point we lack a lot in that. So what's okay? One, do you offer internship? Yes, we do offer internships to our students from CS and IT. We offer a lot of, at least 5 to 7 students a year, we offer the internships. How AI helps in research? Yeah, that is more like a generic question. It's like it's all human, like in the sense, if I'm here in that place, I'll do prompts every day to research more about that domain. So AI helps a lot. Like suppose we are in a land acquisition domain. So earlier when we used to get the knowledge, it was very limited. But now with the help of AI, we research a lot on the modules that we need to develop, and AI gives really good answers in our domain, which is the land acquisition. Okay. How you said in how do we ensure AI development align with human values? Is that you need a strict security and control in your company. Like everything, like in the terms of we are not into Gen AI space, but we are more into application space. So who asked this? Yatendra. So we are right now not in the generative AI, so we are not much about, but we are much cared about our data sets that are generating, if we are building right reports, if it is giving right data to the end user. This is all like legislation in terms of improving efficiency in lawmaking. So this is more like a legal question. You should ask some lawyer, Anushri, in drafting legislation to improve. I think this is like a law thing. So okay, Sachin Sahu is asking students searching better placement. Yeah, even I got placed in 2 companies, and I think student has to apply right now in off campuses a lot. I think we were lucky that we got campuses, but I think the dynamic and even simple thing at our time that interviews used to happen verbally. Now the interviews are happening on machine, so students are very much needed to focus on their practical knowledge, so it will help them a lot. Where can we find how? Yeah, so yeah, for where can we find the appropriate data set? There are a lot of organizations that sell data, so we have to research which field you are looking for data. Like in our case, Esri is the one. ESRI gives the land data to us, all the KML files, all the shape files, so it helps us a lot. And is it good to use AI in research? Yeah, as long as you are ethical, your prompts are ethical, I think it will help you only. AI is there to help you only, right? Otherwise, nobody will use it. So as long as you can do a constructive use, I'll always ask like only good questions to be asked by AI, because see, everything is you should not ask weird question to AI, because it shows your credibility a lot. So I think AI is a good for research. I use AI a lot because the domain that we are dealing right now in land acquisition is very unexplored area. So we use AI a lot for building, for understanding a concept. Any more questions? But yeah, AI is there to help. Like my topic was given, was it a collaboration or competition? It's 100%, nahi, 500%. It's a augmenter. It will help you a lot in your work, but you have to be a partner to it. It's not, you have to use it constructively to help. And in implementing it is one thing, and using it is one thing. So implementation part, even I am not the expert because I'm just end consuming it right now. But implementation part, we need lot of learning towards that, how the infrastructure is set up, how the models are trained. So that learning even is an explored area for me. So I'm trying to research how can we, but from 3 years down to line, we have a plan to move everything into Indian office. So that is good thing which will happen. We will invest heavily in our servers and all GPUs here. So that's what we are doing.
Okay, sir. So
There
it's
is
a
another question. How can we use AI in drafting legislation to improve and precision in lawmaking? As UAE is already implementing it. I think that is a legal question, so somebody from law domain should answer that. I'm not the right person. But yeah, we need every field requires AI. Like it's not only a buzzword, but every field has AI implemented in it. So yeah, please suggest your valuable statement and regarding property tax. Yeah, it is a good. This is it. It systems you are talking about, Ajay Shrivastava, SRIT, are talking about systems or more models?
Sushil sir, please unmute Ajay sir so he can ask question.
How can a student 8th age to get involved? Like as 8th student class should make prompt only, they should start making prompts which are constructive and good. I think the ethical use need to be like we have to imbibe in our students a lot good and constructive use of AI. So they make ethical prompts only to the system because your every history is being tracked on AI systems, be it a Grok model, be it a ChatGPT, Gemini, everything is being monitored. So AI expert, yeah, you have to continuously read and study. I think all the topics are emerging right now. Matlab, I belong to a CSC like 20 years back. Even I kind of learned everything on my own. So yeah, but there are a lot of courses towards it. I prefer LinkedIn Learning. So I have done small, but even I have overview. I'm not a deep expert in it, but it's a vast domain. And yeah, but continuous learning is the key to be a AI expert, I think. Network security, I might not be the right person. Is it good? But yeah, network security, like cybersecurity, is the most emerging field. Like we have a lot of queries also, various threats and intrusions we have detected in our systems, but that firewall was able to capture it. So we were safe. But yeah, network security is one of the cybersecurity, I must say, is one of the most emerging field, and I think it's a very good field.
Okay.
Okay.
It is related to other thing, but
Right,
not
right.
a big deal.
But I'll say,
Uh,
as a techie, I'm running a software company for past 20 years in Bhopal. I think the only skill you need is good problem solving and that aptitude to solve problems and continuous learning. I think all the machines are also getting smarter by doing continuous learning only by implementing the feedback loop. So every day, whenever fresh you are, just learn everything, whatever is on your domain scope. So learning is the key to success here because even machines are getting smarter. And the biggest threat that we see is like machine are getting smarter and smarter. They should not be intelligent more than human. Otherwise, they will dictate the terms and we will follow the prompts. So that threat might be 20 years from now can come, but that will never happen. I hope. I hope. So because we use it ethically. इंडिया में तो नहीं आएगा, but in US might be might be right. So that's but yeah, AI is a very like broad term. I think we can start. Yeah, AI in data management. Yeah, for that you need lot of like these good maths function. There is statistical and all these things. You should be very sharp in that because I think all the languages of R and all those data science you have to explore right now for data management. A lot of analytics is there, but a lot of intelligence making good decisions is there from data management. And yeah, it is very emerging. I can see a lot of data engineers like their ETL pipeline, Azure, Databricks is there. You should read about Databricks. Lot of our everything is now getting into Power BI. I think you might have heard of Power BI. So Power BI is has eaten business of all tools, and you should start learning Power BI also because all the dashboard and intelligent decision making are happening in Power BI, which is a Microsoft product now. So yeah, which is a Microsoft product.
Abhishek sir, can we share your email ID so we can take other participants' questions
Yes.
after your session?
Yes.
Okay, thank you, sir. So Vinny sir, let's go ahead.
Okay. Um, Thank you, sir, for your detailed information on AI and practical implementation in such a interesting way. Now I invite Dr. Anand Bhatnagar to propose vote of thanks.
Thank you.
Very good evening to you all. It is my privilege to propose a vote of thanks for this highly insightful session. On behalf of the organizing committee, I, Dr. Anand Bhatnagar, want to extend our sincere gratitude to our esteemed speaker of today, Mr. Abhishek Kulshresht, the founder of the Flairsoft Consulting Group, Bhopal. His engaging and insightful session, particularly on AI and human intelligence, collaboration or competition, is really beneficial for all of us and will add immense practical value to our FDP. So, a big thanks to you, sir, for sparing your valuable time and your knowledge, sir. Last but not the least, I want to say a big thanks to all the participants for their active presence. Thank you very much, sir.
Thank you. Thank you.
Thank you, sir.
So
Thank you,
can I
Abhishek,
drop
sir,
off?
for the valuable session. Thank you.
Thank you. Can I drop off?
Yes,
Yes,
sir.
sir.
Yes,
Sure.
sure.
See you soon. Okay, participants, the feedback link is already given in the chat box and WhatsApp group. Please fill it and submit by tonight. It is mandatory for all the participants to submit feedback for the attendance purpose. Otherwise, you will be considered absent. That's why it is very important to fill the attendance. Please do it by tonight. The fifth session will be started at 6 p.m. tomorrow. So it is requested to all to be present prior 10 minutes. So thank you all. Good night.
Good night. Good night, all participants.